Most of us love to swim, and we also love to go on vacations where we can experience the thrill of scuba diving, right? However, have you ever noticed that there is a lot of difference in the suits designed for swimming, scuba, and deep sea diving? Why can't we go for a scuba diving in normal swimming suits? It is because if you do so, your lungs will get ruptured. Why does that happen? What is so special in scuba diving suits? You will be surprised to know that differences are due to the pressure exerted by liquids. In this session, we will study a lot about pressure due to liquids and gases and its basic properties. We already know pressure is developed only when the force is applied. What exactly is applying the force on the object placed inside water? Yes, it is water itself. When an object is placed inside water, the weight of water above the object applies the force on that object, which develops the pressure on it. And we know if we go deeper into the water present above us will increase, and with that the weight of the water will increase too. This is why we will experience more pressure. The same can be demonstrated with the help of the following activity. Take a transparent glass tube of length 25 cm and a diameter of about 6 cm. Now take a rubber sheet, stretch it and attach it at one end of the pipe like this. Now ask one of your friends to hold the pipe in the middle and you start pouring water slowly into the pipe. Record the bulging of rubber sheet and the height of water column after pouring some water, and record the same while you keep pouring the water. From these observations, we can conclude that the bulging of rubber sheet is increased as the height of water in the pipe increases. This means the increase in height of liquid column increase the pressure on rubber sheet due to liquid. Let's note it down as the first property of pressure due to liquids. This property also helps in understanding the fact that pressure is different at different heights. Now, what do you think about the direction of force applied by this pressure due to liquids on the wall of this container? With the help of the activity we performed, you will say that pressure due to liquids acts downwards. But that is not exactly right. Why not? Let's do an activity to understand this. Now take a transparent water bottle and make a small hole a few centimeters above its bottom and fix a cylindrical glass tube. Now attach a stretched rubber sheet at its end. Now pour water into the bottle and observe the rubber sheet. Again we observe that the rubber sheet is bulging out, which shows that liquids exert pressure on the walls of the container. You can note it as the second property of pressure due to liquids. Till now, we have seen that pressure applied by liquids increase with the increase in height of liquid column, and liquids apply pressure on the walls of the container. However, is this pressure on the walls equal at same heights? To check this, let's take a used and empty water bottle and make 4 holes at the same heights from bottom. Now pour some water into the bottle. And here we can observe that different streams of water coming out of the holes fall at the same distance from the bottle. This means liquids exert equal pressures at the same depth. You can note it as a third property of pressure due to liquids. The best example substantiating the third property is water gushing out of the leaking joints. You might be familiar with the fountains of water coming out of leaking joints or holes in the pipe supplying water. Do gases also exert pressure? Do they also exert pressure on the walls of the container? Come, let's find out. You close the mouth of the balloon once it is inflated. But why? What happens if we open the mouth of an inflated balloon? Yes, the air escapes through the mouth. Like liquids, gases also exert pressure on the walls of its container, like water leaking through the hole of a bottle. Air also leaks through the mouth. And this is the reason why we can't even inflate a balloon having holes. I think now you understand why air escapes from a bicycle's punctured tire. We have learned a lot about pressure due to liquids and gases. Now it's time to recap through what we have learned. We saw that liquids and gases apply pressure. Liquids and gases apply force on the inner walls of their container, and this force causes pressure. This pressure increases with increase in depth, and the pressure due to liquids or gases will be equal at the same depth. Hope you got to learn some new and interesting things. See you in the next session with more fun and interesting things. Until then, keep learning.